Now that we have introduced exponential functions and logarithmic functions and have learned about some of the properties of logarithms as well as practice solving exponential and logarithmic equations, we are now going to look at some of the applications. Some of them we've covered already a little bit throughout, but now we will specifically focus on first financial applications as well as then exponential growth and decay models. So we're starting in this video with interest formulas, and I will explain the different models that exist, and then in subsequent videos we will practice a little bit, understand the number e, and learn especially then how to apply our logarithm in solving some of our exponential interest equations. So let's take a look at the three different interest formulas, and I will start by explaining what each of the letters mean, the variables, and then we have one example to see how they are applied. So the first interest is the simple interest, and there we specifically calculate the actual interest, and consequently I means interest. Now we're calculating that interest by multiplying the amount that we either want to save or that we borrow, and then multiply that amount with the rate, the interest rate, and then multiply it with the number of years that we are either saving or borrowing, and so t denotes the time. So p stands for principal, which is the amount of money you either invest or borrow, and then r stands for the rate, the interest rate, and we write that always as decimal. And then t is the time in years. So that will cover our simple interest formula, I equals p times r times t. Now what we do there basically is look, if you, for instance, in our example 1, let me pull that up a little bit. In example 1, what we will be looking at is that we borrow, in this case, $2,000 to cover tuition and some books maybe for this term, and we agree to an interest rate of 5%, and we say we're paying it back maybe after you've gotten your bachelor's degree in 4 years. And the question is then, how much will we have to pay back in 4 years given the interest? So with a simple interest, all we basically do, we find the actual interest, which in our case with then p would be with the principal, would be $2,000, and then we multiply that by our rate. Now our rate is 5%, that is 0.05 as a decimal, just divided by 100% per 100, and then we multiply that by the number of years, which is 4 in our case. Then when we put that in the calculator, we end up with $400. Now that is the interest, and so what we all together have to pay back would be our original amount, so our principal plus our interest, be $2,400. That means after 4 years we will owe $2,400. So that is the simple interest formula. Now the next formula, we are taking into account that basically we could, for instance, calculate our interest for 1 year, and so after 1 year, and then whatever interest we have accumulated, we add to the amount, so our principal, and that becomes our new principal for year 2. And then again interest accumulates, and that again gets added to the principal for year 3, and so on and so forth. and that is denoted in the formula of the compound interest, where we basically have that 1 plus something to do with our interest, our rate. So that is demonstrating basically that we're taking the original amount and then adding the interest to it, and then do it over and over and over, which is the reason that we have an exponent, right? It's doing it the same thing over and over, and that ends up giving us a little higher interest, because the principal will grow every single time. And again, that goes for both if I save money as well as if I borrow money. Now here we have another variable, and that is n. So the other variables are almost the same, and then a also. So let's start with n. Now n tells us how many times per year do we calculate our interest. So number of times we compound interest per year. And then lastly, a is the amount that we owe or have, amount after applying the interest. So how does that look in action? Now we are looking into n, the variable n, a little bit more in the next video, where we will calculate for different amounts of interest. In this case, we're just gonna also do once per year. That means n will be 1, and everything else stays the same. So we are looking again at our example 1, and that we are borrowing $2,000 at the same rate for 4 years. Now if we are compounding annually, we have our amount equals, again our principal is 2,000, but then we have 1 plus 0.05 divided by, in this case 1, because we only compounded once. If we compounded twice a year, would be 2, quarterly would be 4, and so on. So, or daily would be 365. So many different ways then to calculate it, and we will discuss that in subsequent videos. So, and then we have to the power of n times t, that would be in this case 1 times 4. And when we plug that into our calculator, we are getting approximately 2,400, but then a little more would be $31.01. So since it's money, we just round always to 2 decimal places, so to the penny. So after our 4 years, you will, in this case, if you compound the money annually, you will owe $2,431.01. Now the last formula that we have is formula where we continuously compound our interest. Now we will get into that in 2 videos down, where we'll look exactly on how that formula comes about. But for now, basically, if you were using your compound interest formula and not just calculate it every day or every minute or every second, but literally every instant of life, which of course is not possible, then that would turn into this formula, would turn to a equals p, again our same principle, times e, our number e, to the exponent of the rate times time. So how would that look? We would have, when we apply that to our example again, so again we would in this case find our a, so the amount at the end, and that is, again, we start with the principal 2,000 times e to the power of the rate, so 0.05, times the number of years, 4. And again, we will plug that into our calculator, and then in this case, 2,442, so kind of roughly another $11 added, and we have still 81 cents as well. So again, after 4 years, you will then owe $2,442.81. Now, of course, you cannot calculate your interest any more than every instant of life. So that kind of signifies the maximum interest you could possibly pay. The reality is often that the interest will get compounded either mostly quarterly usually, or monthly can also happen. So there are different ways, and again we will look into it more, but that's kind of the absolute maximum of that you would have to pay back. So to come back one more time up here to the 3 different formulas for this section, and so 4.7, 4.8, we will mostly focus on the compound interest and the continuous compounding interest, because the simple interest is nothing to do with the exponential applications. It's a linear function, and also it's basically a simple percent problem. So we just included this here to kind of show how the development goes, but our focus will be on the second and third formula, and you are also asked to know them, and you are definitely asked to be able to apply them. And so we will be practicing those now in the subsequent videos.